Can you hear me all right?
Hello, Martin.
Hiya.
Welcome back to Pakistan event. I was just
Thank
we were
you.
just doing some backend checks on the settings up, and you can share your screen. And welcome everyone to Martin. On he will be share details on unlocking business potential, navigating the world of Microsoft AI for future success. And Martin, you can take it from here. You can introduce yourself, and next 15 minutes are yours.
Yeah, thanks very much. So yeah, morning or afternoon, everyone, depending on whereabouts you are. I'll just load up the slides here. I have an ultra wide screen, so we'll just load it on one side to make it a bit easier for everyone to see. Hopefully everyone can see that okay, and that's coming through fine. Let's just make this a little bit bigger for everyone. Okay, so yeah, I guess first of all, apologies for being a little bit late. Some challenges with Teams, as is often the case when you need to join something that's live. But we're in now and we're ready to go. So very quick introduction from myself. My name is Martin, and I'm an app architect in the Azure space at a company called Servent. And we are an Azure consultancy firm purely based around the Microsoft stack, based in the UK. So my role really is to lead app innovation and app modernization. That includes AI. And what I thought would be good to do for this event for you all is there's obviously a lot of talk about AI at the minute. It is everywhere. AI is a big thing, as you'll all know, since ChatGPT and other large language models have appeared in the past kind of year, 18 months or so. Everyone's now talking about AI and what we can do with AI. And I don't know about you guys, but sometimes when I see some of the things that AI can do in the media, it doesn't really hit home for me. There's a lot of things that people talk about that we're really never going to use. A couple of weeks ago, I saw an advert for an AI-powered toothbrush, which is like, okay, I'm not quite sure why we're going to use an AI-powered toothbrush, but okay, someone's put the effort in to do it. So big part of what I do in my role is talk to customers about where AI can unlock business potential. And for me, technology should always be about adding business value and adding business potential. So what we're going to do in this session, I'm just going to give you a really broad introduction to AI, talk about the ethical use of it, look at some of the common types of AI technology that's being used, some of the real world uses of AI that we see today, and then how we actually keep AI secure, which is a big area of focus as well. As with any new technology, and really any technology today, security is first and front of mind. And for me, this is a big area that we probably need to be doing more in. But I think we'll get there as time goes on. So I just want to share some of those thoughts with you as we go through. So I guess the first thing is what does AI mean to people and how do you perceive its impact on your life? And there's obviously lots of things that AI can do. There's lots of things that AI will do in the future, but there's lots of things that AI can do today. And it's today that I really want to focus on in some way. So as far as Microsoft are concerned, and this has come out of a Microsoft deck, is every app will be reinvented with AI, and new apps will be built that weren't possible before, and that's a really bold and big statement to make. But what Microsoft are trying to do with AI, really, in my mind, is reinvent the way we work, not the way the world is imagined. If you look at some of the tools and technology that have been released, in the past year or so, especially thinking about Copilot, it improves our productivity and tries to improve how we collaborate, how we communicate, and how effective we are in what we do day to day. Same with GitHub Copilot. It's, in my mind, especially with a developer background. I don't think it's going to replace developers. Does it complement us? Absolutely. Does it help us do things quicker that we would ordinarily have had to take a while to do? Absolutely. But will it replace us 100%? Maybe. That's not really for me to say, but I think we're way off that scenario yet. So key thing for me is the first part of this. Every app will be reinvented with AI, and it's about using AI to enrich experiences within applications. Okay, so this is a Gartner report. This comes out of a report from the folks at Gartner who say that generative AI has the potential to create between 2.6 and 4.4 trillion dollars in value across different industries and automate different activities that absorb 60 to 70% of employees' time. Now, this is the kind of downside, I think, of the AI messaging is that people see these numbers, especially the last one, and think I'm going to be out of a job pretty soon. But actually, let's just think about it from an automation perspective for a second. If we talk about automation, regardless of the fact if it's infused with AI or using AI models to help with automation, the more that is automated in your role, the more you can think about other things that you ordinarily don't have time to do. So again, this is talking back to productivity and the potential to look at what we do as an industry and what we do within our day-to-day jobs and really look at how we can accelerate the other tasks that we normally don't get to do because we're too busy dealing with the day-to-day tasks. When we automate day-to-day, we can look at tomorrow, which might be product enhancements, it might be implementing new tools for your organization, it could be anything, but it lets you focus on those things rather than firefighting the problems that you have today. So with current apps, the idea is that we have fairly constrained interactions. So what I mean by that is you have a user interface and you input data and it produces a result. And yes, there's business logic in the middle that does various different things, but that is what it does. It inputs data, it processes, and it outputs data. We often work with fixed data sets in there, and we work with hard-coded data in a lot of cases as well. And updating that is often costly, certainly can be complex depending on the application. And every time we get new information, we generally have to make updates to those apps. But if you think about somewhere in the future and the shift around generative AI and making apps truly intelligent, we add natural language interaction, which is instead of us filling in boxes, we ask questions or we ask what we want the engine and the application to do. Using data from ourselves, using data from customers like us, we can get personalized experiences that are based on data. And that's what we call data-driven experiences. And it's those data-driven experiences that enhance customer service. And with all of that, we obviously have the models that then continuously learn and improve based on the amount of times that they're used and how often and how frequently that data is updated. A great example for this is if you think about booking a flight, for instance. When you go book a flight, you have to put in which airport you want to depart from, where you want to arrive, what date you'd like to leave, when you'd like to return, if it's one way, if it's return, how many adults, how many children, how many infants, and finally, depending on the airline, what class you want to fly in. Is it first class, business, or economy, etc. Imagine if a lot of your preferences were then stored in a profile just for you. And instead of filling in all that information, you had a text box. And in that text box, you put, can you tell me how much a flight from Heathrow to New York is, departing on the 15th of September, returning on the 26th of September, and press enter. And then the results are generated based off your preferences and the information that you've entered. And that is what natural language interaction is. Okay, so what is artificial intelligence, right? Artificial intelligence as a term has actually been around a long, long time. And we'll come on to that in a little bit. But artificial intelligence is basically software that imitates human capabilities. And we can predict outcomes. We can recognize patterns based on historic data that we present. We can recognize abnormalities, abnormal events, spikes in data, troughs in data, and we can make decisions based on those events. We can also look at visual input as well. So we can look at images and we can understand language. We can engage in conversations and we can look at different sources of data to gain knowledge. So that could be internal data sources. So quite recently, Microsoft released on their OpenAI platform in it showed the ability to host your own data, where you can ingest your own data sources into the OpenAI models, and you can then interact with those models via an interface very similar to ChatGPT, but it is based on your own data and it is private. So different types of AI workloads. So an important point to clear up, and I know some of you will notice, but some of you may not. You know, AI is actually lots of different disciplines. It's not just what we would associate with generative AI, which is like what large language models and natural language, code generation, those kind of things. The fields of machine learning, the fields of computer vision, document intelligence and knowledge mining. They are all types of common workloads that would appear within artificial intelligence. So it's really important to understand that when we talk about AI, we're not just talking about subsets of the industry, we're talking about much wider topics as well, which include several different areas that are already commonly used today. And we'll come on to some of those examples in a little while. Okay, so the principles of responsible AI. So these are Microsoft's principles of responsible AI. But in my mind, if I'm developing on Microsoft's AI platforms, then I should be adopting at the very least the same principles and any other industry-specific ones that may come to light as well. So I'm not going to go through all of these because there's a lot of text on here, but you know, there's some good examples that you may have heard in the media and in the press. And the first one is a good one, which is fairness. And the challenge and the risk around there is that any bias can affect the results that come out of AI models. You know, let's not forget that an AI model, yes, is data, but the AI model is programmed by a human, and humans are subject to bias. So where we might try our absolute best to not introduce bias, it's really important that we do testing, and it's really, really important that we make sure that we use that testing to eliminate any potential bias that might come out of the results. There's an example on the right-hand side, which is loan approvals. So an approval model could discriminate against gender due to bias in the data in which it was trained. Certainly in the UK, there's a lot about car insurance and that males and females often pay different prices. And that's a great example of where a model may discriminate based on gender and based on the data that it's trained on. And as developers of AI, we need to try and make sure that we are eliminating that bias wherever possible. Another great example on the bottom is accountability. And for me, this is actually a really simple one, but I think it's something that a lot of the industry, other than Microsoft, which I think have a good handle on this now, is who's liable for decisions that AI generates. You've seen a lot of stories in the media. I've seen a couple recently where some AI models set some pricing for products that was wrong. And courts have then said that those vendors and those supermarkets, I think it was, and an airline have to honour the prices that AI gave. There's also examples of where it's told customers how bad the company is that the AI bot is representing. Now, those are kind of light examples, but the main example at the bottom is that when an innocent person may be convicted of a crime based on facial recognition evidence, if that innocent person was convicted and they found that they didn't actually commit a crime, who's responsible for that mistake? we talk about growth mindset a lot in technology, and this is where growth mindset comes in. It's about using that opportunity not to blame people, but make sure that we learn from that opportunity and improve the decision making in the future. So someone ultimately has to take responsibility for any of the decisions that AI can generate. So a very tiny bit on machine learning. So machine learning is basically, dumbed down very simply, a way of creating predictive models by finding relationships in data. So using training data, which would be past observations. So great example would be when you go book a car through Uber, for example. The training data there is everyone's previous trips, where you started, where you finished, how long it took, what the distance was, how much it cost, any traffic that might be en route that would help that. And then we generalize the relationship between the different features and a different label, which we call X and Y in this instance. And we then use the algorithm to train the model. And out the end of there comes a prediction. So in the future, that means that we could go onto Uber's app, for instance, as you do today, as I'm sure many of you have done. And within there, you can effectively go and say, I want to go from point A to point B. It's 10 o'clock in the morning. How much do we think that's going to be? And we get an estimated price based on that information that comes through. And that's something that's really important to understand. That's what machine learning does. It's a predictive model that looks for those relationships between the data. And using that past observation data that we talked about, it's going to say, how many people have gone from point A before to point B? How long did it take? How much did they pay for their trip? And in the future, we are able to give them predictions on how much that is going to cost. Okay, so there are different types of machine learning as well. So there's one called supervised machine learning and one called unsupervised machine learning. So supervised machine learning is where we train data, which includes what we call known labels. So the label in the Uber example is the cost of the trip. It's a numeric value. So if you look a little bit further down the left-hand side of the screen there, you can see where it says label is a numeric value. That's a regression. The example it's got there is predicting the number of ice creams that you might sell based on the day, the season, and the type of weather. Obviously, there's a big difference in whether people buy ice cream, whether it's raining, sunny, warm, cold, summer, winter, autumn, spring. And all of that data can go help build predictions based on that information. So from a classification perspective, where the label is a classification, it's a category or a class. So the label, for instance, could be looking at the example it shows there is a really good one, actually, looking at whether a patient is at risk for diabetes based on clinical data. So you can take lots of different clinical data and the risk factors involved in calculating diabetes risk would be put into the model, and the prediction that comes out the other side is whether that person is at risk of diabetes or not. The multi-class classification, as opposed to the binary classification, is the ability in this instance here, in this example, to predict the species of a penguin based on its measurements. So there's different pieces of information there that are obviously important to going into calculating what type of species we think the penguin is based on its height, based on the length of its beak potentially, and a different number of factors. And that can use multi-class classification on labels to be able to go do those predictions. And then finally, just quickly on unsupervised machine learning data, this is grouping similar items together called clustering. So plants, for instance, are separated out into different classes of plant or different groups of plant based on types of characteristics, what type of flower it is, how it buds, sometimes how it grows as well, what type of water it needs, whether it can grow in the shade or in direct sunlight. And for instance, you might take photos of plants and run it through an unsupervised machine learning model that does clustering to identify what group that should be in based on those characteristics. And those are some examples of how machine learning works. So just moving on very quickly to model training and evaluation of data. So how it works, first of all, so we talked about those past observations. We take that data. In this example, where Y in there is known labels, we take all of that information, we push it through an algorithm that we write within machine learning. Let's say that's a regression formula just for ease. It then goes through, creates the model. We can then pass data in and then generate predictions. What we can do after that, and this is where machine learning and the field of AI can start to become quite clever, is that we can then add that data into the training model and then retrain the model to produce more accurate results. So, it's true to say that the more data you have in an AI model, the more accurate the predictions are going to become. It's no good doing this with 100 or 500 data points. Sometimes, depending on what the data is, you may need hundreds of thousands, tens of thousands, hundreds of thousands, maybe even millions of data points to be able to go calculate accurate estimates. And we can use that data to, again, like I say, to evaluate the model and retrain of multiple iterations. Okay. Another field is along deep learning, which I'm not going to cover too much, but this is around both the artificial and the human neural networks. So as humans, there are electrochemical stimuli in the brain that trigger, and when fired, that signal is passed to connected neurons in our brain. From an artificial neural network perspective, each neuron is effectively a function that we perform that operates on an input value and a certain weight, and that function is then wrapped in an activation that then determines whether to pass the output on or do something else with the data. There are some very specific use cases for deep learning that are not all that common outside of the generalist AI spaces. So we'll just move on to the ethical use of AI. So this is a field which I think is as important and as exciting in many ways as AI today. And the use of AI in society, if everyone could just have a think about what ethical concerns that they have about the use of AI in society. There's obviously some very common ones about bias that we've already talked about, accountability, how your data is used, stored and processed, normal data processing concerns that people have. But some of the considerations that we have to make, I got a few laid out here. Bias and fairness, transparency, privacy and accountability are all things that we talked about. Autonomy and decision making, I think, is a really big one. So the ability to understand how decisions are made. So I can go to a website or an app that uses AI and I can look at how those decisions are made. That's, again, another thing that is quite important for people to understand. Job displacement. We talked about job displacement earlier. This is basically AI replacing people's jobs. There is a risk of that, obviously, but the other thing to consider on the flip side of that is the amount of jobs, the production and manufacturing and the development of AI solutions is going to create within economies. So it's not all just about jobs that will go. There is also a big part of jobs that will be created because of the rapid use of AI, and we're already seeing some signs of that happening, certainly on it creating jobs. Security, again, comes back to privacy to a degree, but how secure is the model and the application using that model, and how is my data used? Informed consent, another big area as well. When we talk about informed consent, this is understanding that your data may be used to train an AI model. That's a big concern for a lot of people. And there are some platforms now which will tell you that your data is used for training AI models. A great example is security cameras, actually, in the physical world. So certainly in the UK, we get this quite a bit, where security footage is used to identify crime and prevent crime. And there's a sticker on the door basically that gives you informed consent that by going into that store, you are helping with the identification and prevention of crime. And if you don't agree with it, you don't go inside basically. And then the last one as well, which I think is a really important point, often gets overlooked, is the amount of compute power needed to run these models is huge, and to train the data in the models is huge. So the environmental impact is a big thing, and being able to understand how we can offset some of that impact and how we can not so much prevent it, because it may not be preventable, but how we can deal with that impact and make positive changes to help have more positive outcomes is a big thing to understand. And we're still learning all of these things about AI. This is a key thing about AI in general. Like I said at the beginning, AI is very new, and we are still learning a lot of stuff around AI as we go through. Okay, so let's have a look at some common use cases when it comes to AI. So image analysis. So you may see this quite commonly in various different walks of life, but being able to group people walking on a street. So you can see the image on there has tagged the fact that there are two people that it can see. The person that's closer to us, they've identified him as male, wearing jeans, having footwear, and they've guessed his age at being 34. No idea if that's accurate or not, but it's basically gone and tagged the visual features that it can see. So this is the sort of image analysis that will be done for things like crime prevention as well. So you may train a model to look for specific characteristics that indicate a crime might be about to be taking place. So someone covering their hood and not showing their face would be a good indicator potentially, depending on the environment. There could be other factors as well that the model's trained on, and it would look to tag those things and alert the relevant people. Face detection. So face detections again is a really good one. We can use the face service in Azure to look at blur, exposure. You can see the examples on there. Glasses, head pose, noise, and something called occlusion as well. So you can see that the face is highlighted in here. So you could use this to count the number of people going into different types of venues, like a crowd control type system. And you could use it to identify different features on people as well. And again, they would be tagged and sent to the application for processing as required. Okay, one of the most common types that I think has been in the industry quite some time now is OCR, optical character recognition, and reading of text. So, for instance, this one is picking up a shopping list, as you can see, and it extracts that from an image. And then for larger documents, you can program the model to look at specific parts of a document and pick out specific areas as you look to move forward and do the various parts of what your application's doing. So text reading's an important one as well. The analysis of forms. So a lot of us, those of us that log expenses at our company, would be familiar with a lot of the technology. So, my organisation uses an expenses system where I can take a picture of the receipt and it'll pick out the main details off there and put them in the right field. I then just have to review it, and if it's correct, I can submit it, or I can make modifications to it before I then submit them for approval. So you can use different types of models to look at common types of documents, such as invoices, receipts, types of ID, and you can train that model to look for specific parts that you need and pull out the data that you then need within your application. Again, it can get quite expensive to train some of this information. So there are hundreds, if not thousands, of pre-trained models out there that you can use for lots and lots of different things. Okay, so what about in the real world then? So just kind of coming up into the last parts of the talk on this, but In the real world, there's lots of different applications of AI today, probably more than you would think. So healthcare, retail, financial services, law enforcement, they are all exponents and users of AI technology today for lots of different reasons. Great example, which is a Microsoft case study, which is based on a project called Project Inner Eye, which produces a product called Osiris, which is something that the Cambridge Hospital University Trust in the UK, in combination with Microsoft Research, also based in Cambridge, look to improve outcomes for patients by building models based on imaging scans for cancer. And the results of that meant that they were able to reduce wait times for treatment, detect cancers up to 12 months before, and speed up a process called oncology segmentation, which is where a doctor looks at a scan image and outlines the healthy and unhealthy parts of an organ. And that process was down to around 30 minutes in some of the testing. As public information, you can go look at that and watch some videos on how it works and stuff on the Microsoft website. If you just look for Project Inner Eye, you will find more details on there. So data feeds as well from a criminal perspective. So the analysis of speed camera data and data from the police national computer can be helped to predict where criminals might be going and focus resources to different types of predetermined locations. And that's something, again, as well as the law enforcement use of image analysis is a great use for AI. Okay, Starbucks. Another great example. Not everyone is a fan of Starbucks, but I've previously done work with Starbucks, and the big thing that I always got taught from them is to not treat us as a coffee company. We're a technology company that happens to sell coffee. So they focus on, again, you can look for videos on YouTube from Microsoft Build on a project called Deep Brew and BrewKit, which are tools that Starbucks uses to deliver customer experiences in store. They use AI in the drive-through, in the mobile app, and the in-store experience to create hyper-personalization of the menu content and what they display on the digital screens based on the stock in the store. The coffee machines are also IoT connected. So at different times of the year, they come out with different recipes for different types of drinks, like at Christmas and in autumn and summer. And those updates are pushed over the air to those machines automatically. Previously, I believe that used to be done by engineers going to stores with USB sticks to update the recipes, whereas now that can be done obviously a lot more efficiently and relatively quickly compared to how that used to work. So how do we keep AI secure? So this is a big kind of area that a lot of people are concerned about at the moment, and how we actually look to keep AI safe. So there's a field called adversarial machine learning, which is around basically crafting specific inputs designed to mislead models. So if you think of information security and cybersecurity methodology today, there are different types of methods that you can use to do that. So we might hire an organization to do a penetration test on our platforms. Think of this as penetration testing, but for AI. And there's two different types of attack methods. So one is called white box, and the white box attack method is where you have internal knowledge of how that model actually works. So you can craft specific responses that you know will break the model or challenge the model into producing different results. And the black box method is where we have no prior knowledge of how that model works. So that might be a traditional penetration test, if you like. It might be a specific way of making sure that we can attack a certain model in a specific way using predetermined methods to be able to go find out exactly how that model is going to respond. Another side as well, so there's some common techniques in there, which I won't go into too much detail because there's quite a lot of complexity in there, but models called FGSM, Deepful, and GANs are all really common techniques. You can find lots of about those online to go find out some more information on them. There's a lot of reading material there, but those are the common methods that we would use in the field of adversarial machine learning. So, how do we defend against adversarial attacks? So, it's okay figuring out how we attack these models, but how about how to defend against them? So, I want to run through a scenario where this works real well. So, if you think of an AI model and the fact that it is trained on data to produce certain results, imagine a data set in that model that produces bad results. What you can do is you can take that model and you can train the data just like you would good data, except this time it's bad data, and we can train the model to detect those bad inputs and produce errors or produce messages that do not allow those types of inputs to happen. Knowledge is also a great area within here as well. And actually, all of the knowledge that you collect about how your model works and how it responds to different types of inputs helps you produce that training data in the future. So if you remember earlier on, I showed up a graphic of the output being trained back into the model. This is exactly where this kind of thing can come into play, but not just for good data, and for bad data as well, so that we can defend against some of these types of attacks that people are making on our models. So in terms of how that might work, so at the top there, you can see that we have our adversary, commonly known as our attacker. We have our training set of data. That data obviously then goes into our model. We produce the tests and we produce wrong output. So we can use this to our benefit to be able to retrain the wrong outputs, to be able to say to the model, hey, if you come up with an output like this, don't show it, show this instead. So there's lots of different ways that can work. Okay, so just to finish off in the last few minutes, I want to talk about some real world implications. So you might have seen this one before. This is from some researchers, I believe in Israel, who were doing some testing on Tesla's autonomous vehicle platform. And what they found is by placing stickers at certain points of signs, it tricked the vehicle's AI system into not seeing a stop sign, but seeing a speed limit change sign. So instead of stopping, the vehicle actually sped up because it thought the speed limit was changing. So again, using the information that we've just talked about, you could use that data to say, hey, when I see this in the future, this is not a speed limit change. This is actually a stop sign. And this is where the risk comes in, and balancing that risk obviously depends on the use case, which is why there'll be certain industries which use AI more than others. Okay, image detection. So this is again a real life use case. So you can see the picture on the left hand side is clearly of a pig, and then what they do is add a fuzz to the image, and that fuzz just looks like nothing to me and you, but what that's actually going to do is trick the AI. The reason you can't see the difference between the image on the left and the right is that this fuzz that's added is 0.005 pixels. So it's very, very tiny. But what the result is when that's overlaid on top of that image and reran through an image detection platform, it says, actually, this isn't a pig, this is an airliner. So if you think of how image detection could be used for preventing crime, it could be used for scanning for different types of objects. That's clearly a big risk that we need to defend against when creating those models. And the last one, again, some examples, image manipulation. So Great example for this is airport security, and we're trying to speed up airport security by using AI to detect certain types of objects in people's bags so they don't always have to be reviewed by a human. But one of the things that we have to be careful of is with poorly trained models and poorly trained sets of data, and I think this just needs moving a little actually, so you can see quite clearly that that is a no, that is the size of the image. So you can see quite clearly the one at the top is a revolver, then there's a boathouse, and then there's a china cabinet. In the adversarial world, what we've done is purely rotate, nothing else, rotate those images ever so slightly. You can see that the revolver and the boathouse is rotated to the right-hand side. The china cabinet there is rotated to the left slightly. But what you can see is that when it's ran through again, those images are not picked up as a revolver, a boathouse, and a china cabinet. So if you think of how that might be used in aviation security, for instance, that's a big risk because there's quite clearly a revolver there that could go through and not be picked up. And this is why quite often the best examples of the use of AI are where AI is used initially, and then the human performs the final validation of the data and the results. And it's that human interaction that we can add on top to improve machine learning. So in that example, you could quite simply have a scenario where that image is picked up. AI says, no, this is not a revolver. It goes through to a human, and a human says, well, actually, hang on, there's a revolver there. They click that part of the image and they mark it as a revolver. And then that data goes back into the training data to retrain the model so that next time it doesn't get picked up. And that's something that's really, really important. Something that's really, really vital to understand is that the human element of the use of AI and the responsible use of AI, I think at this stage, while the technology is still quite new, is vital to making sure that we train data effectively and improve the accuracy of the AI models that we have today. Okay, so just to finish up then, some of the implications of not getting this stuff right. So quite clearly with some scenarios, there are national security concerns. We talked about aviation security, we talked about road traffic collisions as well within this, and the things that we didn't talk about. So from a national security perspective, imagine we're using satellite data to look for the presence of tanks, for instance, and say our attacker is instead found out a way to mask the presence of a tank. What that could do is influence a report into the buildup of tank positions, send a much smaller presence to go investigate, and find that they get ambushed by a large number of tanks. So again, making sure that AI is accurate and making sure that AI is used responsibly, again, with human validation at this stage, is something that is really, really vital to understand. So to finish up then, what we've gone through in here, if I can just go back to the beginning slightly. So we've talked about AI as a broader subject, not just around language models that we mostly associate with AI today. We've also talked about the ethical use of AI and how it should be used responsibly. We've looked at some of the common types of AI technology that is here today that add proper business value, that are not just there to show off some new types of technology. We've also talked about some of real world examples of where AI can be used. And then we've finally wrapped up with how we keep AI secure using the field of adversarial machine learning. So with that, I think we're just about on time. So thanks everyone for coming. I can see there's quite a few of you joined and a few more come through as well. So I hope you found that interesting. If you want to reach out to me, and chat some more, then by all means do that. You can find me on X, aka Twitter. My handle is Mr, which is MR, and then Coops, COUPS. Or feel free to reach out to me on LinkedIn as well if that's your preferred platform. Sorry. So yeah, with that, thanks very much everyone for listening. Hope you found that interesting. And like I say, if you have anything you want to discuss offline, then please feel free to reach out to me. More than happy to carry on the discussion there.